Hello again. This is a tutorial where I will be creating a type of program that can load a picture into a window and you can see it visually, and where you can change a specific object that has a specific color, or all the object that has a specific color from, for instance, green, and change it to red, where all the other colors stay the same, basically. And you can save that picture as well. So it will look something like this. You can take and load, for instance, this picture, a gramophone, and it has this sort of trumpet-like gramophone thing, and it's very green, and this part is also green, and I can just take and change that to red, basically. And this is what we'll be creating, and I can control the intensity, basically, of how much of that is going to take from all the dark greens all the way to the brightest or lightest greens. And you can see, for instance, I can check the red marks and see what pixels exactly are being affected. So this is what I will be creating here. So I can take and load a different picture. For instance, here's a character and this green bit, and it has a little bit of green you see around it as well. We can just take and turn it red, basically, and control how much of that red is going to be affected, so to speak. And yeah, here is also the amount of blue we can control, but because this will be specifically from green to red, and I will explain how that is achieved with, changing the RGB values. Okay, so let's take a new project and with the WPF application, and call it change colors tutorial. And okay, all right, let's lower this one, and I want it on the side instead, so let's make this a little bigger. And in this window we'll start off by implementing a image, sort of an image canvas, and we'll just take this and put it in here, and let's make it larger. Let's make this larger as well, the main window slightly larger, and this one will be specifically, let's see here, let's make it 400 by 400 and put it somewhere here. All right, let's see if it works. And yeah, it works. And we can change the color of the main window as well. Sorry. Let's see here. Like a little bit grayer, so well, you can see specifically between the picture and the background here. Okay, so save this, and we'll start off also by creating buttons. So will be a load, a turn red, and a save picture color. Let's start off with, let's start off, we can increase this, make it bigger here, make these a little bit bigger, and basically this one will be turn red button, this one will be save pick button, and this one will be load pick button. All right, and we'll also change the name. So this one was turn red, and this one was save pick and load pick. All right, so, and this will name image view window. All right, so this will specifically, here we will be creating with pictures that are pretty well low resolution, something a bit lower than 500 by 500, but you can of course make it you can make it bigger. It is possible with the software I created that I showed you recently, but we just keep it to the lower part because it's not very optimized, but I'm sure there are solutions in the future for that. So we'll go and create an event when you click this, and for the turn red, and for the save picture, and for the load picture. And we'll go to turn red, and we'll start out by loading picture. So what you will need is a open file dialog, and since I'm not using anything, so call it dialog, and call it new open dialog, and just hover over this with the mouse and start using Windows 32 here. And we need to filter this dialog when it opens up, before it opens up. So dialog filter equals to, and this is a string that will have image files, and just follow what I write here, like this.jpg, and sorry, okay, .jpg, and that should do it. So if dialog is showing, show dialog, and if that is to true, I'm sorry, if that is true, we want this to we will have to put stuff in a bitmap image. So we create a bitmap image and call it bitmap, and new bitmap image. All right, so we're already creating it over here, but we will create a new every time we load that with the button, because it will clear whatever exists at the moment. So new bitmap image, and bitmap begin init, and these are the stuff we need for basically URI source, and to create a to load the picture basically into the image image grid, or yeah, the image canvas. So dialog file name, and we'll end this with with end init, yeah. And after that, after we receive that information, we will load this into this image canvas. So we'll take that image view window that we called it, and into source, and put the bitmap inside. All right, so image right. I think for the moment that should be enough. We can just try try it out. Let's start the program. All right. Let's put it in. Let's see here. Details. All right. So we'll just take the same guy, and here we have the image. Okay, so now it's basically able to load inside the canvas image box. So after that, these aren't doing anything. Oh, I'm sorry, except for the, of course, the load pick. So what we will have to do now is that we have to create a when we load in a picture, it has a information for every pixel at every position. So that pixel has information for all the red, green, and blue values, which give you the color, the specific color that you need for that pixel. So that next pixel will have another color, and so on and so forth. All those maybe millions of pixels just in one image, you know. So I mean, depending on how big it is. So basically how this works is, I have an example here, is a RGB calculator where you can just RGB works like, if you mix these colors together, it will give you a specific color. So if you only have green while you have all the red and the green, I'm sorry, the red and the blue are 0, you only increase the green, you will get the green. Okay, and if we take that back, and if you can guess what will happen if you take the blue, increase the blue, and it will show the blue. And the same thing for the red, you know. And if we take the red, for instance, and start increasing the green, it will give you a different color. You see, it gives you orange now and goes over to all the way to yellow, depending if these were switched now. You see, this would give you some slightly different colors, some sort of greenish, I don't know, lime color basically. So that's how it works. And for instance, what we will be doing is that if you have some sort of green color, let's say 190 something, this will be at, let's say, just at 95 or 100 something. Blue will be maybe here at 50 something, and it still gives you sort of a greenish looking color, you know. What we will be doing is basically we'll take that specific pixel and we'll switch the values of the red and the green. So green will be, you see, at 100, because this one is at 100, and the red was at 190 or 130 something, 180 or 190. Basically we'll switch that between these two, and you will get that same shade of that specific pixel of that specific color. So this is what we'll be trying to implement into the programming. So we'll have to create two specific classes. One is for storing all the pixel position, and the other class will be storing the RGB values, or well, it will be red, green, blue, and alpha basically. So that we can do by adding a new class and call that class pixel position, and we'll add that, and we'll make this public, and we'll create a pixel position constructor with an int of x and an int of y. I'm sorry. And we will have to link them together with a property. Basically give them set them to a property, these variables. So public int pixel position x get, I'm sorry, get and set, and well, you can just press tab, I'm sorry, write prop and then tab, that's it, and write pixel position y, that's it, and we'll take that pixel position x and feed that with through x, and for the y it's y, and that's it for the pixel position class. So save that, and the next will be add a class and call it RGB a value. Usually people are spelling it from the beginning A instead, but we'll do it like this time. And make this public as well, and give it a constructor RGB value, and this will be a byte, because byte is I think it's 155 different, up to 155 what do you call them, just digits, yeah. So byte R for red, byte G for green, and byte B for blue, and byte A for alpha. So we will create a 4 properties for these. So as I did earlier, prop and then tab. I'll call this red, and I can just copy this whole thing and just, that's it, and change the ones that I need: green, blue, oops, and alpha. Oh, I wish there was a way to just, you know, automatically apply them. Just have to sort of relink everything. G, blue with B, and alpha with, oops, with A. Okay. So, and save this. So the next thing we will create is a image pixel value storage type, where you will basically give it more structure to all the information of the pixels that are available in this bitmap, that you've loaded the picture with all this information, with all the RGB and pixel value, but it doesn't have a very good structure. But so we will copy those pixels and give it more structure, basically. So we'll create a new class, and we'll call this image pixels value. All right, and this will be public as well, and we'll start off by giving a main or global variable, if you will, call it dictionary, and in this dictionary we will take the pixel position that we created and the RGBA value that we created, and put them side by side. So every item will basically have like a pixel position, and the next to it will be the RGB value of that specific item. So pixel X, like let's say 58, and Y 207, an RGB value will be 0, 5, and 27. Let's say it will also have, I think it will have the alpha value, or maybe we'll just ignore it. We'll see what we'll do. So call it get pixel value, and new dictionary, and yes, okay. All right, and we will create a new method, void copy pixel RGB info, and we'll take that bitmap image, and because we will be feeding that bitmap through this and restructuring it, like I said. So all right, so int stride, and we'll take the bitmap pixel pixel width and times 4. I don't know the math behind this, but this is the information I have to how to do this specifically. So take the pixel height and times the stride, and we'll create the byte array with pixels RGB A, and new byte, and the size will be the result of how big the picture is. So take the bitmap, and here is where we will get the information. Basically, I will try to show this when I debug it, and we'll fill up that pixel RGBA, take the stride that we need, and 0 on the offset. All right. If you didn't really understand any of that, I don't blame you, but it's really it involves some math, but I will try to explain the whole show you all the information that contains for every pixel and all the RGB values. So what we'll do now is we'll take a actually, I think it's good that we run this basically, but we'll go to over here and create this, make an object of this class. So we'll take the image pixel value and call it, let's see what we'll call it, and yeah, call it just image pixel value, new image pixel value, yes. And what we'll do here is basically run this after all the information has been loaded, basically image pixel value, and we'll run the copy pixel method, and right, we have to include the bitmap. That's right. I think we should just try to show, yeah, okay, we'll run this, and okay, yeah, sorry, this one accidentally had a plus here, so that was the issue. So let's run this and load the picture, and actually let's load this one. Okay, I think I found the mistake I made here. I accidentally said pixel width here. It's actually pixel height. Sorry, pixel height, and we'll try to run it now. Hopefully it will work. Let's take Yeah, let's take this. And it was able to load it. Okay. Okay, good. So let's just take whatever, and we'll set first a breakpoint here, or actually let's set it. Let's create something. Let's do a debug dot right line. So this one needs a using diagnostics, and I think it's right something. Okay, that was weird. Done. All right. So let's because it will store all the information in here, so we will, yeah, let's take this instead. Let's take it here and put it into pixel value and run it here instead. Oh man. Oh, right. It needs a diagnostics here instead. All right, let's roll. So we have pixel RGB here, and here we have all the values. You see, here is the value of the pixel and everything else, all the colors. Here's the alpha actually. Here's this is the pixels information. So I think it goes like, if you take the picture, if we continue this, and it loads, and it goes the first pixel, second, third, fourth, and blah 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 blah, and all the way then down to the last pixel here. So it goes like a line here, and the next, like, I don't know what the next, like several thousand, 400 whatever, and the next line, and so on. And that's how it creates all these stores into in the pixel RGBA. And this is just an array, so we need to take that information and structure it a little better. So what we'll do here is basically create an int, call it current pixel x, and set it to 0, and int current pixel y, and set it to 0 as well. So, and we'll create a for, and I press tab, and it creates a for loop. And while I is less than pixel RGB array's length, and instead of plus, we'll create it will increase every 4 times instead. So we will, with this, I think we will just ignore the alpha, I believe. So with this, we'll take that get pixel value, and for every new item we will add basically a new pixel position that we have created, and it will have the current pixel X position and current pixel Y position, and we'll just put it on the next line, otherwise the line will be too long. And we'll create a new RGBA value, and in that we will take pixel RGBA and the current I information, because it will jump every jump over every fourth item in the pixel RGBA array, because it will be the alpha. So we will take pixel RGBA I plus 1, and it will be the next in the list. So for that specific, because it jumps over 4, and in that current event we will use, for instance, it's the 0, and then 0 plus 1, it's 1, and then after that it will be the blue. So this one is red, and this one is green, and this one will be pixel RGBA I plus 2, which is blue. All right, and the semicolon. And yes, of course, also the alpha pixel, but we don't actually need the alpha, but because it's a JPEG picture, it never contains any alpha other than black, basically. But we'll do that anyway. We'll include this because it's the 3. Well, this is actually the 4th, because 0 is the first one, so 1 is the second one, and so on, and blah blah blah. So that's why we need 3 instead of 4. All right. So the current X pixel will be plus, we'll add another one, and if current pixel X is bigger than bitmap pixel width, if it's higher than what the width of the picture is, then we have to reset it and set it to 0 again. Okay, but the current pixel, I'm sorry, the X will be set to 0, but the Y will increase, and that will loop through every time. It will go to the next line when the Y is being adding another one to the Y pixel position. So it will be the next, and the next, and the next, and next, and so on. But the X will have to reset itself to 0 every time this one is increased. So because it starts at the beginning and then goes on. So we will, I think it's done actually, this one, and we'll have to go to pixel value and see that it actually works, basically. Let's take this one, and it seems to be working. And now it's loading all the information to this, what do you call, to this dictionary, basically, which is get pixel value, and it structures it much better. So we can at the end here do debug and right line, oh sorry, right line, and say that it's done, and basically start the software and load the picture. Let's load this one, And we can see here now that it's loaded everything, and you see every item, for instance, wait, I'm sorry, every item here, let's take this item and value. The pixel position is at 68 and Y has not yet reached the second line, so it's 0 basically. So value, and it's dark basically. All of them are basically 0, so we can go pretty low for, maybe we will start seeing something. No, not yet. Pixel position, it's on the second line actually. It's kind of dark picture, so yeah, it's on the third, yeah. So, but you can see, continue. You see it's very dark here in the beginning, so it only reach here by the time it's like several thousand probably. It will start giving you a better value. So we can actually take this gramophone again, and it will start giving you values right away probably. Let's take this value. No, not really. It should start giving you something, unless it's very dark. It's like, it's strange if it would be. You see, there's, it starts giving you some values. Okay. Very, very subtle. You see it starts increasing. So let's basically continue and create a class now that will start actually marking the pixels basically, and it will give them basically, in the beginning we'll just mark them just to show the principle of what's going on basically with the pixels, so we know that they are working basically. So it selects the correct pixels. So let's create another class and call it detect color pixel, and it will be public. And we'll create a method which basically everything will be going on here. Public void draw pixels on region bitmap image, and call it bitmap, and we'll have to be using imaging. And we will need the image itself. Sorry, not that one, but image, and call it just the same as image view window, like in that the canvas we have in the GUI. So, and the next parameter, like, yeah, we'll have to choose this one. Yeah, the controls, right? Using the control, and here on next line we'll create the dictionary. We'll need this one, all the structured information that we created for the pixel and RGB values. So pixel position and RGBA value. Right. And call it pixel value, yeah. And we'll also need a int strength, strength, yeah, let's call it like that. String, and choose the color. I don't know how many of these we will actually be using. We might delete them later, but use these for the moment. Red markings and float for the blue color that we will be controlling. I think with a maybe a slider, or we just type our own value in and use that. So create the method here, and in the beginning of the method, and this we will have to do for the image pixel value, I think, as well, is if the image that is being loaded does not have any value, so if the source is null, if it doesn't have anything, return and return and don't run the code, the rest of the code, basically. That's what it's saying. Because if it's null, it will give you a error, a null exception and all this stuff, and you don't want that. So if it does have information, if it's not null, then we will start creating a drawing visual and call it draw vis, and we will be using media, media, and new drawing visual. All right, and if red mark is true, that basically means that we will just show the red markings right now, because the else will be where we will actually change the color, you know, from green to red, and that will be right here. We'll just test this basically to see what pixels are being affected, basically. So we'll be using, because we will just throw away all the memory after this, so drawing context, just call it DC, and draw vis and dot render open, so when it's opened up, and start this image, and we'll take the bitmap. We will have to create on top of this bitmap, on top of this image, basically, a new rectangle. Yeah, but just start using instead. Use system windows and 0, 0, and take the bitmap pixel width and bitmap pixel height. I'm sorry, it took the height here as well. We need the width, and after that we'll say semicolon. So next we'll go through for each in var item in pixel value, and all the information that we stored, we'll take that pixel and we'll see if item value green is bigger than item value red, and what's this, and if item value dot green is bigger than item value blue, and I'm sorry, and if item value blue is less than the strength, and I'll try to explain this as well. So item value, what do we need here, red is less than strength, we will, with that, if this statement is true, all these statements are true, then we will draw in that specific pixel, we'll draw a rectangle, and we'll take a brushes and take the red, and pen will be null, and on the new line we'll create a rectangle and new point. And since we stored all the information here, item key pixel position X, if that's specific, at that specific pixel position, because it's going through all these items, and now it caught this item, it says that the statement is true, and the item of the pixel position X and item key pixel position Y, and the next one is the new point and the item of key pixel position X plus 1. Basically this means that we just want one pixel to take from that point and to the next pixel. That's the length of that specific pixel, basically. I couldn't find any other, other than rectangle and maybe some other, maybe a line or something, to draw this just one pixel, but this is the closest that I've came. So item, and we'll just take the same thing here, and apply it to the Y, semicolon. Basically it will have to draw, okay, and else at this point, if it completed using, and else at this point will be empty. So after else, we will create a render target bitmap and call it target bitmap new render target bitmap, and the bitmap pixel height, pixel width starts with width, bitmap pixel height, and the 96 dpi 96, and pixel format pixel format will be PBGRA32, okay, and semicolon. So target bitmap render, and we'll take that draw viz that we did and make sure that it applies the information with all the new reddish pixels, red pixels, and at this point image view window will have to apply that target bitmap to the source, that new basically, so it shows in the window, in that image canvas basically. Alright, to draw an pixel, and we'll put this into, we'll have to create it of course, detect color pixel, detect color pixel, new detect color pixel, and turn red here, detect color pixel, and call the draw pixel and region, and the bitmap will be the bitmap, and we'll take this image view window and the, I think it's the image pixel, let's see here. So here we'll take the image pixel and object and get, I'm sorry, all right, we'll need to do this public. Sorry, I forgot this. Public. All right, and dot get pixel value, all the stored information for the pixels, and after that we need the strength, which will be, let's put this on like 107, yes, 170 for the moment, and we'll change that to a slider information in the future. So the next one is strength, and the color will be green. I'm sorry, the string, yeah, the string, not strength. The strength, the color will be green of the string, and the bool mark is true, red mark, the bool of the red mark. So, and the blue will be, I think, let's put it at 0.5. It's a float, I think, yeah. So, and let's run this and see if we need anything else. So we load the picture, and I don't know, we can take that gramophone again and turn red, and all the pixels have been detected that are green at that specific strength level. So for instance, if we, let's say, take much less, if it's below 100 and I don't know, 120, maybe that's too low. I don't know. Load pick, and go to gramophone again and turn red. It was slightly lower, and this is where we will attach a slider in the future. You can also, for instance, if we run this again, just I will have to, before I load anything, I will click this and nothing happens. It's because I have set specifically in the image pixel value. No, I'm sorry, in the sorry, detect pixel color, if the source is null, which it is at the moment when I'm trying to turn it red, it will just return. It will not run this code. But I did not set this at the image pixel position. So for instance, if I try to, I think it was when I'm sorry. We'll have to set in the beginning here a specific if statement saying that if the bitmap source, I'm sorry, let's take a look. If get pixel value count is not a 0, if it's equal not to 0, then get pixel value clear. So it clears the information, so it doesn't start adding more when it comes over here again. It starts adding another picture basically, and it becomes a mess after that. And we don't want that, so make sure that we have to clear this. So it should be working now, because if, yeah, I can load this now, I think. So I can clear turn red, and it just turned red. And then I want to load another picture. Let's load another picture. It actually did load another picture, but so if I load another picture, it clears the one before, and now I can turn the other stuff red as well. If I didn't have this, it would, after trying to load the picture, the first picture would be fine, but the next, if I try to load the next picture, it would still work. Okay. Oh, that was strange. Anyway, I will have to split this up into 2 parts. So I thought this would be less than an hour. So this is part 1, and I gave you the basic information on how to detect all these pixels that you need. So the main sort of the whole thing is in this if statement. Basically, it checks the pixel at the moment. If it's less than if a green is less than red, because green has to be, I'm sorry, if green is bigger than red, because it has to be bigger in order for the RGB color. If it's bigger, then it turns red. If this one is bigger, then it starts to look reddish, and it's no longer green, you know. So that's basically the whole thing here when this statement. And if it detects that it is a green color, so detects if green, it will basically draw this red pixel on that specific position of that pixel and make it red basically, and mark it. And in the next part of this tutorial, which might be, I don't know, a week from now or so, I will try to create the next else statement where if it's not the red markings, it will be instead changing the color of that specific you know, object basically. So thank you for watching, and sorry that this part took way too long, way longer than it needed to take. But I hope you watch the next part of the tutorial when it comes out. Thank you.